a graduate research student at CLAC Lab, Concordia, supervised by Dr. Sabine Bergler. Today, I am going to present to you our contribution to the BioCreative 9 MedHopQA track, where we developed and compared agentic and non-agentic multi-op systems for medical question answering. So LLMs generally exhibit strong results in many domains, but for biomedical domains, rigorous evaluations are required before deployment. So to address this, MedHopQA Shared Task introduces a benchmark for biomedical QA that is robust, and as well as it emphasizes on reasoning chains across linked Wikipedia documents. So every question in the dataset require integrating evidence from interconnected Wikipedia documents, testing knowledge recall and complex reasoning. So in this chat task, we submitted three systems leveraging Qwen with Wikipedia and PubMed as knowledge sources. So coming to the first proposed system, so that is an agentic approach system where an agent is a system that leverages AI model to interact with its environment to complete a user defined task. So here an environment could mean consist of tools, user defined instruction and memory. Tools are nothing but functions that can make an API call or query a database and much more. And the user defined query instruction is basically a prompt that instructs that the user provides to the agentic framework to instruct to complete a specific task. And the memory is the history of interaction with the environment of the agentic framework. So how is it suitable for the multi-op question answering? Yeah, so an agentic framework can orchestrate reasoning and tool use across multiple steps, enabling the system to plan, gather relevant knowledge and combine evidence before producing the final answer. So this makes it a natural fit for multi-op question answering. So coming to the methodology, so we used a small agent framework, specifically tool calling agent that basically returns JSON blobs for function calls that is handled by the agentic framework to make the function calls. And so the agentic framework uses Qwen as an LLM that is hosted via vLLM for efficient and faster inference. And we provided a user defined prompt that is specifically for this shared task, instructing it to decompose the input question into a subquery, and this subquery will be given to the tool to retrieve top three documents, relevant documents for that subquery, and then it will use these information and the subquery to formulate the next subquery and so on in a chained fashion. So here the Wikipedia tool and the prompt explicitly enforces to make to not use more than three different subqueries. So this is done because the shared tags mentioned that every question is answered using two interlinked Wikipedia documents. So we gave three just to just for the agentic framework to recover from like any previous mistake in the previous subquery formulation. So every agent every small agent requires step. So by default it is 20, but for this task with the development set we experimented with 10. So but we noticed that 10 wasn't enough for it to reason to reach the final answer, so we increased the maximum step to 15. When we This is when we noticed a good balance between the accuracy as well as time efficiency. So we decided to go with maximum step of 15 for the test dataset as well. So here a step constitute a react cycle, which is basically consists of a thought action observation cycle. A thought is like a plan that is carried out by the agentic framework with LLM, and an action could be an environment tool call or even LLM invocation, and then the observation is from the results of the actions. So, a simple example for a step could be the first step where the input question is decomposed. So, the thought process involves the using LLM to figure out what to do next. So, the LLM uses the user-defined prompt. The agentic framework will give the user-defined prompt to the LLM, which will observe that the environment doesn't have any memory. So it will try to formulate the first keyword specific subquery in the action cycle, and in the observation cycle it will extract the subquery. So this is constitute a step, and it goes on to the next step where the retrieval happens, and further like subquery formulation and so on, and to the final answer step. So the final answer step is basically a JSON with long and short answer. So yeah, that is about all about the system 1. And coming to system 2 and 3, so since we noticed in the agentic system that it is using one prompt where like every step is autonomously managed by the agentic framework in terms of reasoning, and we do not have any control over intermediate step, so leading to difficulties in refining the reasoning step and also tracing the errors. So to address this, we propose another alternative, that is non-agentic system with explicitly controlled pipelines. So coming to the methodology, so we have an LLM driven iterative pipeline which contains a series of steps and termination condition. So yeah, the steps are nothing but sub-question generation, query formulation, information retrieval, sub-question answering, and evaluation step. So basically, uh, we generate sub-question from the input question, and we generate a query from the sub-question which we can use it to retrieve information from Wikipedia and PubMed for system 2, and from Wikipedia for system 3, and we'll try to condense the information by making use of LLM to answer the sub-question. And then we have an evaluation step that uses LLM to evaluate if enough information is already there to, or does it require more information to answer the input question. So that is all the steps we have. And coming to information retrieval, as mentioned earlier, Wikipedia retriever is used by both system 2 and system 3, and PubMed is used only by system 2. So Wikipedia retriever is used by system 3 specifically to compare the system 3 with our agentic approach to see how well it performs given it uses the same information sources. Yeah, coming to termination condition. So we have a termination condition at the beginning of the loop where like we have an odd cap on iteration, that is we do not generate more than 3 sub question. This is similar to the agentic approach where we cap the subquery calls to 3 in system 1. So we did the same thing over here, and we also have an evaluation step additionally to make it more efficient. So not every question needed like breaking down multiple times. So we had an evaluation step that uses LLM at the end of the loop that will check if the history of sub questions and its answer is enough to answer the main input question or not. So if it's not the case, it will try to formulate the next sub question using the history of sub question and their answers in a prompt template. So all these steps uses LLM except the information retrieval steps. So this is what the termination condition is all about. So coming to final answer step, it happens across 2 different steps. So the first step is to produce a long answer, which is using like sub question answers and the input question. So once it answers the once we have the long answer, we'll use the long answer to produce a short answer with respect to the input question. So this is all about system 2. So coming to evaluation, the test set contains 10,000 questions, within which 1,000 questions are concealed, which will actually be evaluated. So there are three levels of evaluating an answer, that is surface level, concept level, and reasoning level. So coming to results, so as you can see, like the system 1, which is an agentic system, and system 2 is a non-agentic system with two information sources, that is Wikipedia and PubMed, and system 3 is just Wikipedia. So these are the three metrics. So the first metric is like surface level match, and this is improved exact match is also surface level matched with improved string matching, and concept level is synonym level matching. So the long answer reasoning level results are not yet out. So as you can see here, the system 2 performs much better than other systems, and the system 3, which we developed for comparison, is clearly much better than the agentic approach as with the same information source. So coming to the analysis, we noticed that the non-agentic system with performs better, so indicating controlled, iterative, and modular pipeline is more robust for the biomedical question answering task. So we are augmenting domain specific information, that is PubMed. PubMed provides like more of a medically related content with encyclopedic knowledge, that is Wikipedia, enhances the performance as observed with system 2, and addressing each step in isolation allows greater and control and targeted optimization. So coming to conclusion, so I conclude by saying for biomedical task, it's better to have controlled modular iterative RAG systems that provide finer control over reasoning, retrieval, and answer synthesis than a monolithic agent system that uses just one prompt, and which faces struggles with refining intermediate reasoning steps. So as compared to the non-agentic approach, where we can optimize every step, thereby making the application robust for the biomedical task. And adding PubMed as an external knowledge source improves performance by providing richer domain-specific context. And also, it is clear that LLMs can answer question and can perform question answering in other domains in a single step, but it's not the case for biomedical question answering that requires complex reasoning. So, and results reveal trade-off between the flexibility in agentic framework, where the approach is pretty straightforward. The agentic framework takes care of most of the things, provided we give the tool and the user prompt, and against the traceability in control pipeline, where like it's a trade-off that that is dependent on what is more important. Like if considering a medical task, if accuracy is the most important factor, we could consider a non-agentive approach. But if flexibility is more important, we can consider an agentic framework that is lightweight, like SmolAgent. Yeah. So thank you.